cosine of 240 divided by 2 minus cosine of theta. That's going to be cosine of 120 minus cosine of, 240. Cosine of 120 is negative 1/2 minus cosine of 240 is negative 1/2. Negative and negative is positive. You end up with 0. That's checked out. So 0 works, 240 works, 120 does not. Make sure you learn to check your work, especially when you're squaring both sides of the equation right here. Okay, guys? Number 8 was finished. Let's do, so 14 minutes has elapsed so far. Let's do number 10. The sign. Oh, we forgot to check our work on the solution survey. Number 0. Let's go. Number 8. Number 8 is 0 and 240. 0 and 240. Worked out. Perfect. Number 10. The sine of 3 theta minus 45 degrees equals negative root 3 over 2. And I want all of the solutions between the interval. We're still in the same directions. So this, when is the sine of this angle? Let's call this x equal to negative root 3 over 2. Well, I want to see how they look at the answer on that. Oh, they did it that way. Okay, fine. It's a little bit easier method when it says all solutions between 0 and 360. You're going to have a little bit of a problem. I like the way they did the solution. I mean, not the solution, the answer. So I'm going to try to mimic what they did in the answer. Excuse me. This 3 is going to kill you. So what you have to do is, not that bad though. For sine of what angle would equal negative root 3 over 2? We know that the reference angle is equal to 60 degrees. And when is it equal negative? In quadrant 3 and quadrant 4. So at quadrant 3, quadrant 4, the reference angle is going to be 60 degrees. So 3 theta minus 45 is equal to quadrant 3. We add 180 to that. It would be 240 plus 360k. Don't forget to add the 360k. Okay. 3 theta minus 45 degrees has to equal, in quadrant 4 is 360 minus 60, which is going to be 300 plus 360k. And you can write down k equals 0, 1, 2. That's the 3 rounds that you saw here. You're going to do the first round, the second round, and the third round. So let's rewrite this again. We're going to add 45 to it. 3 theta is equal to 285 plus 360k. And 3 theta is equal to, add 45, 345 plus 360k. Okay, got that so far? There's not enough space here, so I'm going to use the next page. Let's just rewrite the problem. 285 plus 360k. So what we do is we divide by 3, divide by 3, divide by 3. That gets rid of the data. 285 divided by 3 is going to equal 93. Is that right? Is that 83 or 93? I'm not sure. On number 10, it's 95. Yes. 95 degrees, 360 divided by 3 is 120 degrees K, where K equals 0, 1, 2. Don't forget, the first round, you end up with 95. The second round, you have to add 120 to that. Third round, we add 2 times 120, which is 240. The second one, so that's your first answer. The second one is 345 degrees plus 360 degree K divided by 3 to both sides because it was 3 theta. Okay. 345 divided by 3. 3 goes into 34 8 times, 25. No, 3 goes into 34 9 times, excuse me. 9 times 3 is 27. No, what am I doing? 1, 1, 5. Plus 360 divided by 3 is 120k. Let's see if that's right. On number 10, it's going to be 115 plus 120k. Okay, good. I just checked it right here. So number 10 is finished. Let's do the next problem. I'm going to reference this paper right over here, so just in case. Number 12. Sine of theta minus cosine of theta is equal to 1. Now, as I stated in section 1, chapter 6, as well as section 2, I believe, or was it section 2 and 3? There's two ways to do this type of problem. There's about a 50% chance it's going to give you something like this on a text. Your teacher, that is. I don't know who your teacher is. I really don't care who your teacher is. Sorry. It's not my problem. It's your problem. Get that? It's not my problem. But anyways, let's get started. So we add the cosine of theta to the sides. Sine of theta is equal to 1 plus cosine of theta. Remember, there's two methods. One, we could just square both sides, but you're going to have a problem with the O and the I in FOIL. That's the reason why I prefer not to do it that way, but it's your preference, not my preference, so you can do whatever you want. Now what we do is we square both sides, because we have to have everything in sines and cosines. So when we square the left side, we get sine squared of theta is equal to, with FOIL the right side, 1 plus 2 cosine of theta plus cosine squared of theta. If you learn to FOIL these out with the outer and the inner. If you're not sure, just write it one more time and just FOIL it out. Okay. The reason why we squared it, as you can see, that sine squared should be familiar to you. It should look like 1 minus cosine squared of theta. That's the Pythagorean theorem. So that's equal to that. I'm going to move the cosine to the right side, subtract 1. In fact, the 1 cancels. Subtract 1, subtract 1. I end up with 2 cosine squared of theta plus 2 cosine of theta is equal to 0. I added cosine squared theta plus 2 cosine theta equals 0. There it is right there. Now looking at that equation, it's pretty simple from here. We factor out 2 cosine of theta, then you end up with cosine of theta minus 1 equals 0. When we finish it up, we zip it out. Cosine of theta equals 0. Cosine of theta minus 1 equals 0. As you can see, I'm kind of still in my ropes, maybe. I am in my ropes. Cosine of theta equals 0 at 90 degrees and 270 degrees. And cosine theta equals 1 at 0 degrees. So those are your 3 answers. Box it. Again, we have to check our work. Because of the squaring, we're going to get extraneous solutions. Sine of theta is 1 minus cosine of 90 is 0, so that checked out. Sine of theta, let's check this one, write it out. Sine of 270 degrees minus cosine of 270 degrees equals 1. Sine of 270 is negative 1 minus cosine of 270 is 0 equals 1. Negative 1 equals 0? Absolutely not. So that doesn't work out. But the intuition, the reason why we want to look at when we square both sides, the reason why we want to look at the extraneous solution is, excuse me, what am I saying here? Does not equal 1. When we square the left side and square the right side, negative 1 squared becomes 1. On the right side goes 1. But from the original problem, right over here, sine theta minus cosine theta equals 1. The original answer did not work. But when you square it, it becomes equal. That is the reason why we have to check for extraneous solutions. Let's try 0. Sine of 0 is 0 minus cosine of 0 is 1. Negative 1 does not equal 1. Only one solution worked out. Let's see on number 12. 90 and 180. Oh, did I get it wrong? Where did I get it wrong? Cosine of theta equals 0. 90. When is cosine of theta equals 0? Not 90. Yeah, that's 270. How come they're saying 90 and 180? Let's move this guy to the right side. Sine of theta equals 1 plus cosine theta, equals squared, sine squared theta plus 1 equals 1 plus 2 cosine theta plus cosine squared theta. We got that right. The one sine squared theta is 1 minus cosine squared theta. That cancels out with that. Again, cosine squared theta, 2 cosine squared theta plus 2 cosine theta equals 0. I drop 2 cosine theta. There it is. Oh, shoot. Plus 1. Found my mistake. Oops. Sad face. Okay. Let's try that again. All right. Backtrack, as you can see, guys, backtracking is really difficult. And I have to concentrate really hard when I'm backtracking I'm going to try to make the same errors over again. So I have to be very careful when I'm backtracking. Same with you guys. So let's do this again. 2 cosine of theta equals 0. Cosine of theta plus 1 equals 0. Cosine of theta is equal to 0 at theta is equal to 90 and 270. And cosine of theta equals negative 1 at theta equals 180 degrees. So it should have been 90, 270, and 180. We checked 90. We knew that 270 didn't work. Let's try 180. It's the original problem. Sine of 180 minus cosine of 180. Does that equal 1? Sine of 180 is 0 minus cosine of 180 is negative 1 equals 1. Negative and negative is positive. That worked out. Glad I checked my answers here. Okay. Okay, next problem. This is, I don't know what page it is. I believe it's page 3. 1, 2, 3, 4. Page 4. Whoops. Page 4. We just did number 12. Let's do number 14. It says radical 3 sine of x minus cosine of x is equal to 0. It says find all solutions. This time, you're going to use in radians. So problem number 13 through 18, we are not going to do parametric equations. That's out of the scope for most teachers. So we're going to do 13 through 18 in radians. Okay, these are the rest of the directions. So let's get started. First, we're going to do, if you square both sides,